This is Lab 2 for Physics 2212. We're looking at magnetic fields of specifically a bar magnet. So the introduction, the purpose of this lab was to measure how distance impacts the magnetic field of a bar magnet. So we're looking at the observation location being further out from the bar magnet. And the main physics principle was Biot-Savart's law, which is the magnetic constant times V cross R or all over r squared, and the results were the magnetic dipole moment, which was found to be 4.513 amperes meter squared. The system was the magnets and the surrounding was the earth. The initial conditions, so like I said, the magnetic dipole moment was found to be 4.513 amperes meters squared, and then the distance was 0.1 meters, and then d perp was 0.196 meters. So the data was tracked with a magnetometer, and it was used to track the magnetic field, not electric field. Please ignore that. And this led to a bunch of potential sources of error, which I'll get into later. And then these were the bar magnets that I used, so the cheapest that I could find off of Amazon. So that was also a potential source of error. So this is the main portion of the code. Basically, it just is able to track the actual magnetic field of the magnets depending on the location. And the main def portion is where we actually calculate the magnetic field. So yes. And then here are results from the experiment. I had no idea how to open up the sheets that were actually in the lab instructions. So instead, I just put the averages onto this sheet. And here is the linearization of the graph for the natural log of R and the natural log of the magnetic field of X. So here are the results from the code. You can see the on-axis and off-axis arrows, and also the directions and magnitudes of them as well. So potential sources of error. As I've mentioned, there are a lot of potential sources of error. The main one was electronic interference. While doing the lab, we did have to use our phones, and this can obviously cause issues with the magnetic field of your phone, also interfering with the magnetic field of the bar magnets. And then in addition to that, like I said, I got kind of the cheapest magnets off of Amazon, so there's a very high likelihood that some issue came across because of that as well. So the what if question in the experiment, you oriented your setup as to compensate for magnetic north. What if you hadn't done that and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? So the Earth's magnetic field would have interfered with the measurements of the bar magnet's magnetic field, and this would have resulted in a change by weakening the impact of the bar magnet's net field or strengthening it depending on which direction we're orienting the bar magnet. But this is just because E net would be like canceling itself out. And then what does it mean? Imagine you had two identical magnets. What if you redid the experiment, but instead of using a single magnet, you used two identical magnets stuck together end to end? How would you expect your measurements to differ? The magnetic field strength would potentially double, but the actual direction would remain the same, because no matter how you cut a magnet, the magnetic north and magnetic south pole will always be in the same original locations. So depending on how you're orienting it, if the north pole is facing up and your south pole is facing down, if you add another magnet, the north pole will still be up and the south pole will still be down. I think I said that in the right order. I'm sorry if I did it for the second time. But point is, they'll always be in the same location. Thank you.